Solutions for high-dimensional data with KNN. Say you have 980 features, even if they are non-correlated, which is a big assumption and unlikely in real-world scenarios. You should definitely consider dimensionality reduction or feature selection techniques before applying KNN. Dimensionality reduction. Principal component analysis, PCA. This is often the best choice. PCA transforms the original features into a smaller set of uncorrelated principal components that capture most of the variance in the data. This addresses the curse of dimensionality by reducing the number of features while preserving important information. SNE, T-distributed stochastic neighbor embedding, SNE is primarily used for visualization, but it can also be used for dimensionality reduction before applying KNN. However, it's computationally expensive and not suitable for very high-dimensional data or large datasets. It is also not deterministic, meaning running it multiple times might yield different results. UMAP, Uniform Manifold Approximation and Projection. UMAP is a more recent dimensionality reduction technique that is often faster and better at preserving global structure than SNE. It can be a good alternative to SNE for dimensionality reduction before KNN. Feature selection. Filter methods. These methods select features based on statistical measures like correlation, mutual information, or chi-squared test. They are computationally efficient but don't consider the interaction between features. Wrapper methods. These methods evaluate subsets of features by training a model on each subset. They are more computationally expensive but can find better feature subsets. Examples include recursive feature elimination, RFE. Embedded methods. These methods perform feature selection as part of the model training process. Examples include lasso regression and tree-based methods. Locality-sensitive hashing, LSH. LSH is a technique for approximating nearest neighbor search in high-dimensional spaces. It uses hash functions to map similar data points to the same buckets, allowing for efficient search of approximate nearest neighbors. This is useful for very large datasets where exact nearest neighbor search is computationally infeasible. Which method to choose? For your case, 980 features, PCA is likely the best starting point. It's relatively computationally efficient and effective for reducing dimensionality. If visualization is important, SNE or UMAP can be used for visualizing the data in a lower dimensional space, but they are not the primary choice for dimensionality reduction before KNN due to their computational cost and stochastic nature. If you have a very large dataset and need fast approximate nearest neighbor search, LSH can be a good option.